Welcome back, students. We'll be looking at section 5.1, terminology for product rule and power rules for exponents. So let's do a little bit of review first. So remember, our little number at the top that's attached to a normal number is our exponent. And the normal number, this 7 here, is what we call our base. Also remember that the base number is what we would multiply by itself however many times they tell us with the exponent. So like this one is to the 4th power, so we would multiply 7 times itself 4 times, and that would give us the 2,401. Also remember that this can be written out in 3 different ways. We can write it out with the parentheses, which is what I normally use. You could use the multiplication symbol of the x. Wouldn't recommend it because you're going to have variables in some of these problems and it would get very confusing. Or you could use the dot in between. Again, that would be okay, but probably the best option would be the first one with the parentheses, because it's going to be the most clear of what's going on versus the other 2 options. All right, so we're going to put the term exponent in this first blank. Remember, it tells us how many times we're going to multiply that number by itself. And then the base of an exponent is only the number or variable directly attached to that exponent. That's very important in these sections, because you're going to be doing simplifying problems with multiple exponents, and you need to know what that exponent is attached to and which one will actually be affected. So, example, this 3 times x to the 5th power. The only thing to the 5th power is that x. We're not going to do 3 to the 5th power, okay? It's not attached to the 3. The other thing that I want to remind you about is this right here. I spent a great deal of time in a previous video going over the difference between these 2, but I want to reflect on it again just because it's that important. So remember, if there's no parentheses, like this one right here, what you're essentially saying is -1 times 7 times 7 equals -49. Your number is going to stay negative in this scenario. If you have the parentheses, like this one, where that negative is in the parentheses with the number, then it's going to look like this: -7 times -7, and a negative times a negative, you know, is a positive. So we end up with a positive 49. So make sure you pay close attention to whether or not there's a parentheses around that negative or not, okay? All right, so we're going to look at some new terminology now. We have what's called the product rule for exponents. The product rule says that x to the power of m times x to the power of n equals x to the power of m plus n. And all this is demonstrating is that when you have this scenario here, you're going to add your exponents together, okay? So let's look at a couple of examples. 8 to the power of 4 times 8 to the power of 3. So the way I would write this is 8 to the power of 4 plus 3. We're adding our exponents. Now, I do have to make sure that my base, whether it's a number or a variable or a symbol, that they are the same. I can only combine exponents with like terms, so that's important. These both have an 8 for our base, so I can combine these. So that would simplify to 8 to the 7th power there. Now, I'm not going to go ahead and finish this out and do 8 to the power of 7 because that would be a super large number. But the way you would solve that is you would just multiply 8 by itself 7 times and get this humongous number. I want to focus on how we actually combine the exponents when we do these examples. The next example has a to the power of 2 times a to the power of 6. So again, I'm going to write my base, which is the same. Our base is an a. And then I'm going to write 2 plus 6. So that combines to a to the power of 8. Our next one has two variables. We have c and d. And so we have c, d. The d is to the power of 2 times c to the power of 7 times d. Okay? So I need to look at my c's and recognize that this c here has an invisible exponent of 1. We just don't write it. It's just understood to be there in math. Just like we have the invisible 1 other places, we have an invisible 1 here. So when I set up my blank here, I'm going to have c to the power of 1 plus this 7 over here that's with that other c. 7. And then I have my d that I need to deal with. I have d to the power of 2 plus, oh look, we have an invisible 1 with this d here that's not written. So 2 plus 1. And that simplifies down to c to the power of 8, d to the power of 3. So not too complicated. This is fairly simple. What becomes complicated is when you learn the other rules and you have to keep the rules straight when you're solving problems where you're using multiple rules for one problem. So it's really important that you really focus on fully memorizing these rules so that when you get to the mixed problems, you're able to recognize this is where I use this rule, this is where I use that rule, okay? The rules themselves aren't difficult. It's when you get to the problems that use multiple rules within that one problem. All right, so let's look at the next one. We have 5m squared times 3m squared. All right, so I've got a 5 and a 3. They don't have the squaring number, but I do have the m that is a like term base that I can combine my exponents with that. So I'm going to go ahead and do that part here. So m to the power of 2 plus 2. Now we need to deal with that 5 and that 3. They're normal numbers, so we're just going to multiply them. 5 times 3, okay? So let me rewrite this so we can see that. I want to give you this written out so that when you look back at it, you know exactly what we did to get our answer. So 5 times 3, and then we had m to the power of 2 plus 2. This is where students tend to make a mistake. They go, oh, the rule tells me to add my exponents, which is right. But they forget that the 5 and the 3, we need to treat like a normal multiplication problem. And then they add them rather than multiplying them. So be very careful. These rules are only for the exponents, okay? If you have numbers that are being multiplied, treat that like you would a normal multiplication. So 5 times 3 is 15. And then we have m to the power of 4. Our next example has 4x squared y times 3xy cubed times 10x squared times 2y to the 4th. All right, so we've got to look and figure out how are we going to combine all these x's and y's and also multiply our numbers correctly. So the first thing I'm going to do is I'm going to go ahead and multiply my numbers. The 4 times the 3 is 12, times 10 is 120, times 2 is 240. So I get 240 here. Now I'm going to look at my x's. My first x had a 2. My next x has an invisible 1 here. So I'm going to put plus 1. My next x has a 2. So I'm going to have a plus 2 here. So I've got all my x's done. Let's look at our y's. I have y to the power of 1 here. So I'm going to start with 1 plus. My next one is a 3. And then my next one is a 4. Now we're just going to simplify those and actually add them. So I end up with 240 again. My x is going to be, let's see, 2 plus 1 is 3, plus 2 is 5. My y is 1 plus 3 is 4, plus 4 is 8. And that's our answer. We can't go any further. Now let's look at a few examples that do not follow the product rule. We have to be very careful to make sure that the problem we're looking at is a problem that would use the product rule. We don't want to get tricked. So this is a couple examples that do not follow that. Our first one has 5m squared plus 3m squared. It looks a lot like this one up here, but there's a difference, and the difference is this plus sign. This one had multiplication. This is not going to be a product rule problem. This is an addition rule problem. So what we would do is say 5 plus 3 is 8. And then we keep our m squared. Remember, when you're adding values with exponents, first off, they have to be like terms. The m's have to be the same and the exponents have to be the same. And you keep them the same. You don't actually add them. So make sure you pay attention to the difference between these two problems. Okay, so these are different rules. And this is where I was saying sometimes students get confused on whether or not to multiply the numbers or not. All right, another example that does not follow the product rule is 4 to the power of 9 times 2 to the power of 3. We cannot use the product rule here because they have different bases. The power of 9 has a base of 4, and the power of 3 has a base of 2. So we can't use the product rule here. So they have different bases. Now that doesn't mean we can't solve it. It just means we can't use the power rule. What we would have to do is actually do 4 to the power of 9 and get a humongously large number. And then do the 2 to the power of 3, and then multiply those numbers against each other to get our final number. But we can't use the product rule to get there. That's the important part that I wanted to show you. The next one has 2 to the power of 4 plus 3 to the power of 3. All right, so remember over here, I said we could actually combine that m squared, those two together, the 5m squared plus the 3m squared, because we had m squared, the same bases attached to both of them with the same exponent with addition. This one, we have different bases. The 2 is not the same base as the 3. We also have different exponents. We have a 4 and a 3. So we can't add these in this way. We also can't use the product rule because it's addition. So we're going to put here different bases, and it's addition, not multiplication. Okay, so I'm going to write that over here too. Addition, not multiplication. So that doesn't mean we can't solve the problem. It just means we can't use the product rule to solve it. Power rules for exponents. All right, so now we're going to learn a new rule. So when you have a base to an exponent within a parentheses to another exponent, it's basically being raised to a different exponent, then this is what you would do with the rule, okay? So I'm going to write this one in a different color. You're still going to have your base. Let me change to a thicker marker here, just so we can see it better. You're going to have the same base, but your exponents, you're actually going to multiply them like this. So the previous rule, when you're multiplying your bases, you add your exponents. When you have an exponent raised to an exponent, you're going to multiply your exponent. That's the difference. All right, so let's look at this one right here. We have xy to the power of m. All right, so that, because the xy are they're in parentheses, we're going to be using the distributive property. So distributive. So we're going to distribute that m, that power of m, to everything in that parentheses. And so it becomes x 1 times m, y 1 times m, and that just becomes x to the power of m, y to the power of m. I wanted to show you this part because don't forget they have a power of 1. But this is our final answer of that rule, basically. The next one has x over y in a fraction form to the power of m. We're still going to use that distributive property. And we're going to distribute to everything in that parentheses. So again, we have an x to the power of 1 and a y to the power of 1. So I'm going to write that out. X 1 times m over y 1 times m. And we get x m over y m. And that is the final answer of that rule. But I wanted to show you the in-between so you can see how I got there. And use that as your pattern going forward. All right, so let's look at a few examples of those. It's basically the same rule. It's just showing you 3 different versions that you may see that rule in your work. All right, so let's look at the first example. 5 to the power of 3 to the power of 4. So I'm going to write 5, and then I have 3 times 4. It fits this version right here. And then I get 5 to the power of 12 because I multiply that 3 times that 4. My next one has 6 to the power of 2 to the power of 5. Again, it fits that first version of the rule. So I have 6, 2 times 5. So I end up with 6 to the power of 10. My next one has x to the power of 4 to the power of 2. It's basically the same version of that rule. So x to 4 times 2, and that gives me x to the power of 8. Now, make sure, again, that you're very careful when using this rule versus this rule. It's very easy to get it confused and to add rather than multiply or multiply rather than add. So make sure you really pay attention to what the problem is and really focus on what rule you need to use so you don't get it confused. Don't rush through these. If you rush, you're going to make errors. All right, so 4x to the power of 5. Let me scroll that back down a bit. That looks like this rule right here. Okay, so I'm going to switch. That's this rule right here. Same rule, we're just going to be distributing this time. So I have 4 with a power of 1. I also have that x with a power of 1. So I end up with 4, 1 times 5 up here, x 1 times 5 there. And that becomes 4 to the power of 5, x to the power of 5. Next one. We've got a lot more in this parentheses, but it's going to be the same process. We're going to distribute that power of 4 to everything within the parentheses. The 2 has a power of 1, and so does the y. So we end up with 2 to the power of 1 times 4, x to the power of 2 times 4, and then we have y to the power of 1 times 4. This becomes 2 to the power of 4, x to the power of 8, y to the power of 4. And hopefully you can write smaller than I did on here to get your answer to fit in there. All right, let's look at the next one. I have 2 on the outside of the parentheses and a to the 4th, b to the 2nd power on the inside of the parentheses. And then I have an exponent to the 3rd power outside the parentheses. This is the first one where I can really show you it really matters knowing the difference between what is the base and what is not. The base of this power to the 3 is only what is in this parentheses. That is the only thing that that power of 3 is attached to. This 2 out here, that's not attached to the power of 3. So it just stays 2. Now I need to distribute that 3 to everything in here. So I get a to the power of 4 times 3, b to the power of 2 times 3, and that results in 2a to the 12th, b to the 6th. So again, it's really important you pay attention to what is actually your base. Our next one, I keep wanting to scroll up, but then remember I want you to be able to see the rule. Our next one is this version here. So I'm going to do those in red so you can see them. All right, so 4 to the third, or excuse me, 4/3 to the power of 2. That is how you have a power of 1 for each of those. So you would say 4 to the 1 times 2 over 3 to the 1 times 2. And you get 4 squared over 3 squared. And if the problem wanted you to simplify it, 4 times 4 is 16. And 3 times 3 is 9. Since that one gave us a small number, I went ahead and did that one. The next one has 2c over 3d to the power of 3. So I'm going to distribute that 3 to everything that's in here. And they all have a power of 1. So that's 2 to the power of 1 times 3. C to the power of 1 times 3. Over 3 to the power of 1 times 3. And then d to the power of 1 times 3. And that becomes 2 to the power of 3, c to the power of 3, over 3 to the power of 3, d to the power of 3. Now, some of your problems will want you to go ahead and finish out your numerals, like that 2 to the power of 3 and the 3 to the power of 3. And if it wants you to do that, go ahead and do that. We don't have room here, so I'm just basically wanting to focus on the rule. Don't drop my pen. All right, so let's look at the next one. X squared y over w to the third, z to the fourth, and all of that is to the power of 2. All right, so let's distribute to everything. So x to the power of 2 times 2, y 1 times 2, because we got that invisible 1 there, over w to the power of 3 times 2, and then z to the power of 4 times 2. And that gives us x to the fourth, y to the second, w to the sixth, and z to the eighth. Okay. And that is our answer. You'll notice that I write out all of the pieces so that I can see them clearly. Please, please do not do this in your head. Please write out every single step. These problems are so easy to make an error, especially when you do these in your head. And you will get the majority of them wrong rather than right if you don't write out these steps. That is a promise I can make you. All right, so let's look at this next one. We have -3 squared in the parentheses, and then we have a 4 on the outside. What we need to know is there is a rule associated with this that we have a negative inside, okay? That exponent that's outside, this exponent right here, is what's going to determine if we end up with a positive or a negative answer. That is an even number. So when we pull that out, we need to pull everything out like this. 3 to the power of 2 times 4. Okay, we're going to actually change that 3 to a positive version of itself because of that even exponent outside the parentheses. That's the key. It's the number outside the parentheses. And that's going to become 3 to the power of 8 right here. And if I was to finish that out, I would get 6,561. Just to kind of show you. All right, our next one is a -3 to the power of 2 in the parentheses, but we have a 3 outside. The 3 is an odd number. So that tells me I'm going to keep that negative with my 3. It becomes 2 times 3 up here. I end up with a -3 to the 6th power, and I end up with -729. So when you come across a problem like this in your homework, quiz, or test, make sure you look at this so you can remember the difference between the two and how that will affect your answer. All right, let's look at some mixed problems here. We have 2m to the power of 5 times 2m to the power of 3. We've got two rules here that we're going to be using. We've got the power rule and we also have the product rule. I need to distribute first, okay, and then use my product rule after that. So I'm going to distribute the 5 to everything. So I end up with 2 to the power of 5, m to the power of 5. And then I get 2 to the power of 3, m to the power of 3. Now I'm going to use my product rule, okay? So this was the power rule to get here. Now we're going to use our product rule. And this is why I said it's really important to truly memorize what these rules are, because you're going to need to know when to use which one and not get them confused. So now we're going to use the product rule, which says 2 to the 5th power plus 3, because I'm combining my 2. And then I have m to the 5th power plus 3. And that becomes 2 to the power of 8, m to the power of 8. And that problem has now been simplified down. Now, again, they may want you to fully simplify your number out, which that would be 2 to the 8th power would become 256 m to the 8th. So if they want you to do that, then that would be your answer. If not, then what I have boxed in would be your answer. And it would just depend on the instructions of the problem. Let's look at the next one. We have negative 3xy squared to the power of 3 times x squared y to the power of 4. We're going to use the product rule to start with. So let's do that. So I'm going to change colors just so we can recognize the difference between the two problems. All right, so I'm going to distribute that 3 to everything that's in here. And I get negative 3 to the power of 3. And remember, that 3 is an odd exponent, so that keeps my negative 3 negative. That was that part up here that I was showing you, okay? So it's a lot like this one here. All right, so we've got negative 3 to the power of 3, x to the power of 3, y to the power of 2 times 3. Then we have x to the power of 2 times 4, y to the power of 4. I'm going to simplify that out. We get negative 3 to the power of 3, x to the 3, y to the 6th. And then we have x to the 8th, y to the 4th. Now we need to use our product rule and combine our variables and their exponents. So I still have negative 3 to the power of 3. That hasn't changed. X becomes the power of 3 plus the power of 8, because I've got these two here. And then y becomes 6 plus 4 here. That's going to simplify out into negative 3 to the power of 3, x to the power of 11, y to the power of 10. So it's not difficult. You just have to take your time and write out each step. Recognize here, we did a lot, and if I didn't write out those steps, it'd be very easy for me to get things confused. All right, so let's look at our next one. Again, we're going to distribute. Change colors here. So we've got 2 to the power of 4, x to the power of 2 times 4, y to the power of 3 times 4. Then we have, let's see here, 3 to the power of 3, x to the power of 3, y to the power of 2 times 3. Simplify that out. Let me erase just a little bit of this one so that I can have more room here. So we get 2 to the power of 4, x to the power of 8, y to the power of 12, 3 to the power of 3, x to the power of 3, y to the power of 6. This next step, we're going to use our product rule. I'm also going to go ahead and simplify out my 2 to the 4th and my 3 to the 3rd power. So actually, let's go ahead and do that in this previous step. That 2 to the 4th and that 3 to the 3rd. Let's write what they will become, because I'm going to need to actually multiply them against each other. So I need to know what they are. So 2 to the 4th is 16. 3 to the 3rd is going to be 27. All right, now let's move on to our next step. So I have 16 times 27. That's 432. And then I have x to the power of 8 plus 3, y to the power of 12 plus 6. Simplify that, 432, x to the power of 11, y to the power of 18. And that is our answer there. All right, let's do a quick review of our formulas here for shapes. We have perimeter, we have area. I put this in here so you'd have this here and you wouldn't have to flip all the way back to where we went over this before. But I'm not going to do a review in this video because that would take up valuable time. But just make sure you look back over this and reflect on what you use for what shape, basically, or angles. So let's look at using area formulas for a rectangle and a triangle. Remember, the area of a rectangle is length times width, and our triangle is 1/2 base times height. All right, so our rectangle, I need to write my sides as though they're being multiplied against each other because it's length times width. So I have my 6x squared times that 2x to the power of 3, y to the power of 4. I'm going to use my product rule. So 6 times 2 gives me 12. Let me write that a little bit lower just so it's a little more spread out here. It's 12. And then x squared and x to the 3rd, I need to combine those with the product rule. So that's x to the 2 plus 3. And do the same thing with my y. Oh, I only have one y, so that just stays y to the 4th. Simplify that. I get 12x to the 5th, y to the 4th. And that one is done. Okay. All right, let's look at our triangle. We have our base as 4x squared and our height is 5x cubed. So let's fill that in. So we get a equals 1/2 times my base, which is 4x squared, times my height, which is 5x cubed. A equals, that 1/2 times that 4x squared becomes 4/2x squared. And then that's going to be multiplied against that 5x cubed. I'm going to go ahead and reduce my 4/2. That becomes 2x squared times 5x cubed. And then I'm going to use the product rule. So A equals 2 times 5 is 10. And then we have x squared plus the 3rd. And we get 10x to the power of 5. So our area of that triangle is 10x to the power of 5. All right, let's look at our quote here. In most sciences, one generation tears down what another has built, and what one has established, another undoes. In mathematics alone, each generation adds a new story to the old structure. Herman Hankel. All right, guys, hope you're having a great week. I'll see you in the next video. Bye.